Welcome. So now we're going to be graphing on the coordinate plane from a point that's not the origin. Right? This one's not in your notes, but the next one is. So we're going to draw the dilation of triangle ABC with center P and scale factor 3. So we're going to use what we've learned, but we have to adjust it. We can't just multiply our coordinates by our scale factor because those are distances from the origin, not point P, and point P is not the origin. All right, so step one, we're going to find the distances from our point of dilation in this case it'll be a point P. So I'm going to find the distances from point P of the dilation to the points on the pre-image. Right, that'll be our step one, and we'll put it in a matrix. All right, so from P here, you have to go 1, 2. Oh, let me add one last thing. Direction. All right, so if you go right or up, that's going to be positive. If you go left or down, that's negative. Let me move that over just a teeny bit. And then right, that refers to x, left refers to x, up is y, down is y. All right? Now we got everything. All right, so our A, B, and C as distances from P. All right, so I have to go 1, 2 to the right, and I'll put the 2 in there, 2 to the right, and 1 up. All right, so you go from your point to the figure. All right, so that's 2, 1, because I'd have to count 2 in the positive direction horizontally, and 1 in the positive direction vertically. How about to B? All right, 1, 2, 3. I have to go 3 in the positive direction horizontally, 3 to the right, but nothing vertical. Right, so 0, no vertical change. And then to C, all right, 1 to the right and 1, 2 down. All right, so that distances is 1, negative 2. So if P were the origin, that would be the coordinates for A, B, and C. So if we just change the coordinate plane so that P was the center. All right, so now that's step one. Step two, we're going to multiply our distances to P and P will abbreviate that for point of dilation. Distance, and in this case it happens to be P. Multiply distances to P by the scale factor. All right, so this one was step one. Step two, we're just going to multiply these by 3, and that's going to give us step 2. Right, so this is just, this isn't going to be the real A prime and B prime and C prime. This is going to be our distances. We're going to have to convert those to coordinates. All right, but then that's just one last step. All right, so A here is at 2, 1. If we multiply by 3, that's going to be 6, 2. If we multiply 3, 0 by 3, that's 9, 0. And 1, negative 2 by 3 is going to be 3, negative 6. Right, so that's step 2. Step 3 you have to convert the distances to actual coordinates. And it's super easy. All you have to do is just add the coordinates of point P, your point of dilation, to your distances. Right? And so this is step 3. So if we look at our point P there, our point of dilation is located at 1, 2, 3, 4, so -4, +1. All we have to do is add -4, 1 to all of our coordinates, and now they aren't just going to be distances from point P, they're going to be actual location. Right? So we just convert it by adding in what point P was. Right? So I'm going to add, so this is this A, B, C, this is just distances. This one's going to be the actual coordinates. All right, so I'm going to add -4 to all the x's first, and then we'll add a 1 to all the y's. All right, so 6 minus 4, that's going to be 2. And 9 plus a -4 is 5. And 3 plus a -4 is -1. And then 2 plus 1 is 3. 0 plus 1 is 1. -6 plus 1 is -5. All right, and so now let's graph. And so step 4 is just graph. And you're going to graph the actual coordinates, not those distances. And I think, yeah, I think my figure is going to be smack dab in the middle of my matrices. Well, one coordinate is going to be smack dab in the middle of my matrices here. So I'm just going to move them down slightly, and then hopefully everything will fit. And if not, well, I'll just graph in a different color so you can see it. There we go. And bring B and C down. Step 3, move that down. I only have to get as far as -5. And actual coordinates are right here. Bring that down. There we go. Whoops. And we want that. And there we go. There's the last of the numbers. All right, so I'm going to graph it in another color, so maybe it'll stand out if it is still in the middle of the coordinate of the matrices here. All right, so we have 2, 3, 1, 2, 1, 2, 3 right here is going to be the actual A prime. 5, 1. So that's 2, 3, 4, 5, 1. Here's B prime. And then C prime is at -1, 1, 2, 3, 4, 5. Right. Still in the matrix here, but if I move it down a little bit, then there we go. And so now let's connect. So A prime to B prime. Whoops, that's not straight. To C prime, and then back to A prime. Let me get rid of this. Yeah, I think I smushed I think this line kind of bends in. I made my triangle a little bit skinnier than it's supposed to be. My shadow is sometimes blocks. There, I think that looks a little better. My shadow sometimes blocks where it is I'm supposed to be going. And so sometimes I'm guessing, and that's not good until I move my arm out of the way. All right, so let's see if I can get C out of there. That's fine. We'll leave C in there. Now, there's another way you can check to see how well you did in terms of your graph. And if you remember, if you connect your point of dilation, it should intersect, assuming my lines are straight, I got that one, with the point on the image and the point on the original. Right. Now, granted, sometimes my dots aren't exactly where they're supposed to be. That looks a little better. All right. And A is correct. It's just the A is written way off. A prime is way out there. But, oops, let me fix my, but it's got to go through A. Did we make a, oh, we have a boo-boo. Wait, 1, 2, 1, 2, 3. So, did I miscount? Let me just graph that one more time because that's a horrible, horrible looking triangle anyhow. All right, let's count that one more time. All right, so we have 2, 3. 1, 2, 1, 2, 1, 2, 3. Now why is this one being off? I have no mistakes in multiplying, right? I can multiply by 3. And 3, -6, that's good. And subtract should be 2, 3. And I had just done this, and it was fine. We'll check on that one. 1, 2, 3, 4, 5, 1. Sometimes it's not easy to see these lines up here, and I could easily be off. And then 1, 2, 3, 4, 5. And there's C prime. All right. A little better. What has happened to our A? Unless my line is going too high through the coordinate, the original point of dilation. Let's see. We fix him. Well, I think it's just because the point's so big that I'm kind of hitting the top of the point and not in the right location. Also, my arrows are huge. Let's make sure we're not hitting the top of that. There we go. All right, there we go. So Ray was just in the wrong spot from the point of dilation. So I'm standing back here, and yeah, point 3 should be right here. There we go. All right. So you can kind of use those as guidelines. All right. And you'll be able to see it better than I can up here. The next one's in your notes. All right. And so we'll do that one together. All right. So these are going to be our steps. All right. So you're just going to find the distances. All right. So basically, you just have 2 other steps than if it were around the origin. You got to find the distances. That's one step, and then you got to add the original point. You got to add that point of dilation in, so you actually turn those back into coordinates. Those are the only 2 extra steps. Let's do this one here. Right. So draw a dilation of triangle ABC with center P and scale factor 2. I think I can write down here. All right. And so put this in your notes. Step 1. Find the distances from point P to the points on the pre-image. And we will go over the directions one more time. All right, so if we go right or up, that's positive. And down, I want to stay with the same direction, or the same horizontal or vertical. So right and up are positive, left and down are negative. Right, and then right and left, that's X, up and down, that's Y. Right? So, and we'll put the matrix up here, I guess. All right, so this would be step 1. And I'm going to try to make sure it doesn't end up in the middle of a figure. Oops. turned away for a second, and one letter was on top of the next. All right, so step 1. All right, so we're just going to count. All right, so I'm coming from P. All right, so A. Actually, let me slide this down a little bit so I can fit in A prime, B prime, C prime, or A, B, C. All right, so to point A, I'm going to go 1, 2, 3 to the left, so that's going to be -3, and 1 up, so that's going to be +1. So this is -3, +1. Let's do the same thing for B. 1, 2, 3 to the left, right? So that's -3, and then 1, 2, 3 down. So that's -3 as well. So -3, -3, and then, so you can see it's 3 to the left and 3 down. And then let's do the same thing for C. Right? So now 1, 2, 3, 4, 5, 6 to the left, and 1, 2 down. So that's going to be -6, +2. All right, so those are going to represent our coordinates, right? Because those are the distances from our point of dilation. If we don't convert them, then we're just going to have a mess. All right, so step 2, we're going to multiply distances by the scale factor. Right, and that's going to give us the new distances. All right, so we're going to multiply those times, our scale factor is 2. All right, so then A prime, B prime, C prime, these ones are just distances. They're not the real coordinates. We got to convert them. I don't know, I would call them something else, but I can't think of anything else to call them. All right, so everything gets multiplied by 2. Right, so -3, 1 becomes -6, 2. And -3, -3 becomes -6, -6. And -6, 2 becomes -12, 4. And uh-oh, I was trying to avoid, well, we'll just graph our figure right on top of our words here. It'll be fine. Right, and then step 3. Right, we need to convert distances to actual coordinates by adding point P. Right, so we're just going to add, and it's listed right there, 6, 5. Right, so we're just going to add 6, 5 to everything, so that's step 3. Oh, and I didn't label it, but this was step 2. All right, and actually maybe I'll put it over here. All right, step 1, step 2, step 3. All right, so that's going to be our actual A prime, B prime, C prime. Oops, oh, crooked there. All right, so -6 plus 6, that's going to be 0. And let's add 6 to all of our x coordinates. All right, so -6 plus 6 is still 0. -12 plus 6 is going to be 6. Oh, actually, we should be okay. Yeah, we'll be fine. Our words aren't going to be on top of our figure at all. All right, and then our next one. All right, so 2 plus 5 is 7. Actually, no, even the matrices will be okay. The figures won't even be in our matrices, I don't think. -6 plus 5 is going to be -1, and 4 plus 5 is 9. Maybe 1 point. No, actually, I think it'll just be under our matrix. All right, so now step 4 is graph. And we'll graph the actual coordinates. And then I'll just put in a step 5. This one's an optional. And we'll do it on this one. Check. Right? And that's going to be with the raise. All right, and so we'll graph 0, 7, 1, 2, 3, 4, 5, 6, 7. Just makes it. And that is A prime. Right, and then B prime is going to be at 0, -1, right there. And C prime is going to be at 6, 9. And let's see. Did I? -6, 9. Excuse me. -12 plus 6 is a -6. -6, 9. I'm like, it can't pass the other points. -6, 9. All right, so 1. No, it's really hard to count. 1, 2, 3, 4, 5, 6. All right, I think that's -6. And then 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, well, one of them will be in the middle of the matrix, but the other ones are okay. All right, somebody seems off. Ever have one of those days? Let's see. Oh, I know why it's off. Whoops. We wrote something down wrong. Remember, it was 6 to the left and 2 down. I put a +2. Sorry about that. That makes that a +4. That changes that to a 1. Well, I told you I knew that was wrong. Just have to be careful with your values, whether it's up or down. And it's okay to make a mistake, all right? So I made a mistake there. The thing is, when you make a mistake is, don't just go with it. Go, whoa, that's not right. Did I write something down wrong? And C is going down. It has to keep going down. It can't have been positive. It had to be negative. All right, so if you make a little mistake, you fix it. No big deal. All right, now let's graph this. -6, 1. 1, 2, now I got to count again. 3, 4, 5, 6, 1. That looks much better. All right, C prime. Now it'll really look good if my lines are straight and our rays hit where they're supposed to. Maybe I shouldn't use such thick rays. Let's use these rays here. I'll use a thin line. All right, so if I go through, whoops, and I actually have my line straight. If we have a ray and we start it at the point of dilation, it should go through the image and the original, right? Otherwise, we might have a boo-boo, or maybe our line is crooked. So far, so good. A is good. B is good. How about C? And we don't need to go that far, but there we go. And C is good, all right? So that's how we knew C was in the wrong location before. And actually, let's make those stand out. Oops. I don't want, oops, sorry about that. I added an extra. Oops. There's not supposed to be any more lines coming up. All right, you go away. You go away. Just to make that a little clear, let's make those another color. What color do you like? Green? Well, it's green because I hit green first. And this one will just be, oh, look at that blue, or aqua, or whatever the color that is. And heck, hey, why didn't it change colors? And this one here can be aqua. That one changed. All right, let's make that one change. Purple it is. All right, so now you can see that if we draw the rays, it goes through our points. So that one is definitely looking good. All right, so this is how you check. All right, ours with those rays. All right, and that's all there is to graphing around a point that's not the origin. Thanks for watching. Bye for now.